animation for you here, and I want you to. There we go. You can watch this and think about what it has to do with what we're talking about. Pull that down a little bit here. So hopefully you started working on the homework, and then this relates back to last class. So let's watch this. So it starts here. This is the start of it. And then this is part 2 here. Starting over, here we go. That's the beginning. All right, so hopefully this animation should conjure up some ideas from last class. So can you relate it to what we're talking about? So maybe take a minute to talk to the person next to you. All right, so this is about the area between curves, right? That's what we're talking about? That's what this is about? Yes? No, it's nothing to do with area between curves. We have not talked about area between curves. If that's what you're saying, then you're not in touch with what we did last time. Try again. It's nothing to do with area between curves. Go. In fact, it has nothing to do with area. It has nothing to do with area at all. Anything else? So, yeah, Ryan.
Is showing like a double integral.
Okay, something about what about a double integral?
Which variables you're integrating like first.
Okay.
So it shows that like you're integrating along y. So that's when the first part of it where it goes up like that.
Okay.
And then it shows how you're integrating that across the x spectrum.
Okay, that's well said, right? So this is saying, all right, let x be fixed and integrate with respect to y. And then we're going to take all those and integrate those with respect to x. So then what can we say further then? So if we're integrating with respect to y first and then x, that's what this is type. This is illustrating a type 1 double integral. That's right. Where it's what? dy dx. And what was our mantra for that? Bottom function to top function, then left value to right value. Okay, so then it doesn't have to do with area, but it's a two-dimensional figure, so what does it have to do with volume? Does it have anything to do with volume? Some people were saying volume, but it's two-dimensional, right? It's a two-dimensional picture, so if it has to do with volume, how does it relate to volume? Yeah, Christian.
It would be like this is the region of like a surface that is above it.
Right. So this is the region in what?
R2.
In R2 in the xy plane. So we got some this. Right. So we got some kind of region in R2, and so then that's what I'm showing here, just the R2 version of the region. And then, so volume comes into this how then? Yeah.
Because the function is three-dimensional.
The function is a surface, right? F of function z is a function of x and y. And so what does the double integral find then?
Net area under the curve, under the surface.
Net.
Net volume.
Yeah, so it's going to find what does that mean, net volume? Doesn't it just find volume? Doesn't the double integral? So what are we talking about? We're talking about the double integral of f, right? In this particular case, dy dx over the region. So does it find volume? Does it find volume, that double integral?
below and become negative.
Okay, so it's maybe it does. When does it? If this function, if z is positive for all xy points over that region, then it will find volume, right? The bottom of the solid is, the bottom is what? The xy plane. The top is F, and the sides?
The integration bounds.
Defined by R, defined by the edges of R. So it could find volume if this is always positive. Then you get this volume where the top is the surface, the bottom is the xy plane, and the sides are defined by R. But it doesn't necessarily. What it always finds, what we always can say is that it finds what we call net volume. So there's different types of net volume or signed volume. We could say it's signed. And what do those mean? In essence, what does net volume or signed volume mean?
Change in volume.
Not really change in volume. Yeah.
The amount of volume over the xy plane?
Well, that's will be part of it. But if this surface goes down below the xy plane in the region R, then the double integral won't be just the volume above. What will it be? Yeah, the difference, right? So it would be any volume over R, any part of the solid that's above is like positive contribution to the double integral, and then any volume that's below the xy plane, that volume gets subtracted out in terms of finding the double integral. So this is what this means. It means difference of volumes. The sum of the volumes above minus the sum of the volumes below the xy plane. That's what net volume or signed volume means. So if it's always above, you get volume, right? If it's always above, you get volume. If it's sometimes below, those will get a negative assignment, and those volumes get subtracted out when you calculate the double integral. So the region and the limits of integration is a R2 phenomenon, right? So the limits of integration is an R2 phenomenon, like defining what that region is in R2. In this case, type 1, bottom curve to top curve, left to right. Then the whole double integral brings in the surface in R3, and the whole thing is this idea of signed or net volume. Okay, does that help? So let's just summarize that. Here I got a slide. So here, this is type 1. Bottom function to top function first, then left value to right value. Bottom to top, left to right, dy dx. So first, like that, like we saw in the animation, and then we're going to integrate all those from left to right. Okay, so then what is type 2? Type 2 is where your functions, you're conceiving your functions as kind of a left function and a right function. And so in type 2, we go left to right first, and then bottom to top. So that's dx, dy. So first, for a constant y, you integrate with respect to x, and then we're going to integrate all of those from bottom to top. Okay. So do you see how we can focus on just R2, what that has to do with it, but then the whole double integral is an R3 thing when you bring the surface, the function that you're integrating into it. That's the R3. Okay, so here, one important thing is to, given integrals, can you sketch the region in R2? And then change the order. If it's type 1, change it to type 2. And if it's type 2, change it to type 1. And here's the strategy for that. Changing the order of integration means 1, sketch in R2. Make sure you understand the region you're given. 2, scrap the old limits. Don't try to change the order by looking at these numbers. Make the sketch. Do it by the sketch, right? So you make the sketch based on the limits of integration, and then based on the sketch, you rewrite it in the other. So then rewrite limits based on sketch, not the old limits. Okay, these are geometry problems. They're based on they're based on the functions that you sketch. You're gonna define these regions based on the functions that you sketch. Not try to do some kind of tricks with the values and the functions and the limits. Okay, make the sketch, scrap the old limits, and then rewrite based on your sketch. Rewrite it. Okay, so you're gonna have a good chunk of the class to work on these. This is if you can do these, then you understand double integrals pretty well. Okay, so these are good exercises. So take your time to think, work by yourself, but I always encourage you to work together as well. Okay, let's do the first one together, and then I'll let you work again. So this is what, type 1 or type 2? Type 1. So what it's saying is, it's saying that 3x is what? The bottom. And 24 is the top. And 0 is the left. And 8 is the right. So we're going to sketch 3x, right? We're going to sketch 3x. And we're going to sketch what? Y equals 24. And then we're going to think about this region. Well, the region, let's see. The region is 3x is the bottom boundary and 24 is the top boundary. So is that here, exhibit A, or here, exhibit B? If 3x is the bottom boundary and 24 is the top. Exhibit A or exhibit B? B, right? This is the bottom here is 3x, and the top is 24. And so we want as much of that as from starting at 0 and ending at 8. So here's starting at 0, and then ending at 8 happens to be this intersection, but it wouldn't have to be, right? So it could be 0 to 6. If it were 0 to 6, then it would look like this. It would still be bottom to top, and then 0 to 6, but 8 ends up being the intersection of those two. So we're going to go all the way to the corner. Okay, now what? So we got this right here. And now the goal is, now we're going to rewrite it as type 2, dx dy. So dx dy means, what? First, we're going to go left to right. So what's the left side and what's the right side? The left side is 0, And the right side is, it's going to be a y value, right? But expressed in terms of x. So it's y expressed in terms of, no, sorry, x. It's the x value expressed in terms of y. So this is the x value expressed in terms of y, which would be 1/3 y. So the left side is 0, the right side is x equals 1/3 y. And then now from bottom to top. So that's going to be from, where's the first one of those? Y equals 0. And the last one is 24. So notice how I got those new limits from my sketch. Not from trying to do like some shenanigans with those. Once you make the right sketch, get rid of those old, scrap them, and then go to your sketch to come up with the new limits. Does the process make sense? Okay, now you can work on the other ones. And now, if you have a question on that, you can.
Yes, I'm going to start from 0.
Okay, so I put the answer to number 2 up if you want to check that. For number 3, this represents all one region, right? So when you draw the region, there's one region that you're drawing. It just needs to be split up when this is the order of integration. But so you don't draw 2 different regions. Draw all one region, one graph. What? Did you do 2? Yeah, that's what I'm saying. Because then once you look at it as one region, then you can use the most efficient way when you change the order.
Because we drew it as if.
Yeah.
Yeah,
You don't want to. It's not 2 separate problems, right? It's one region, and when you change the order, you might be able to write it as one integral. And so you need all one region to do that. So make sure you get that region correct.
Split it up into 2 integrals.
Can we do 1 or 2? Do we need 2? So does yellow show up? So going left to right, does either the left side or the right side require us to split it up? The left side, you see that? The left side requires that we split it up. So one of them will be here. You don't have, so 4 doesn't matter from left to right. You don't have to go from 2 to 4 and then 4 to 14. You can just go all the way from 2 to this function, right? And then, but for higher values of y, the left side will be x plus 1. Do you see it? So, when y, and so what is this? This is that 3? So when y goes from 0 to 3, x goes from 2 to whatever this is solved for y, right? Because we're doing dy. So 2 times 7 minus y?
Is it the x dy? Because we're switching.
Yeah. So as y goes from 0 to 3, x goes from 2 to this, whatever this x value is. Minus 7. I think it's 2 times 7 minus y, is that right? No, because I switched to 7 minus y, so y minus 7. So negative 2y plus 14, is that what you got? Okay, then plus. Now y is going, when y goes from 3 to 5, our left side is what? y minus 1, and the right side is
Still 2.
the same thing as this.
So you should walk your right body is always going to the side, right? Because at the very top of that. Oh, it's going to be fine. And the first time you find it. So you go. So you left that one. The rest is.
Make sure you understand this. Do you follow it? Where did I lose you?
Oh, did you just plug it? Two plus
Yeah, this is this. So this is the y value. That's the breaking point,
Okay.
right? For the left side. The left side is constant at x equals 2 up to 3,
Okay, yeah.
and then it's this x plus 1 from 3 to 5.
Yeah, okay.
Better?
Yeah.
So the left side, 2, x equals 2, x equals y minus 1. But the right side is always this function here. The right side is always this function.
I'm confused by your balance there, because wait. So the first double integral goes from 0 to 3.
No, it should be.
But how can you?
Yeah, so x goes from 2 to this line when y is between 0 and 3. See that?
Yeah. Okay.
See it now?
Yeah.
And then it goes from this line to this line when y is between 3 and 5. Better?
Yeah. I was confused by your first gold line. It's like drawn under 3. So
Yeah, so it's all, that's a typical, right? Any y value from between 0 and 3.
yeah, I was just thinking that was your balance.
No. I'm drawing the typical y value. So we're going to integrate all of those starting at 0 up to 3. Okay, any more questions about number 3? Yeah, please.
So I split mine at x equals 4. Like number 1 is my first one.
Then you'd have to write 3 integrals. You don't need to, but you'd have to write 3 because you'd have to write from here to here, and then from here to here, and then from here to there.
So couldn't you just do from, so I did the integral from 0 to y minus 1 of the integral of 2 to 4 of x, y, dx, dy.
But if you go from 0 to y minus 1, you're integrating stuff that's not in the region. You said from 0 to y minus 1?
Yeah.
Those are x values. The lowest x value we have is 2.
Yeah, that was my y. So I went from, by integrating my y, my bounds were 0 to y minus 1.
0 to,
And the x was 2 to 4.
you're mixing and matching x's and y's.
Okay.
If you go from 0 to y minus 1, that's implying that you're looking at x values. And so an x value of 0 is here from 0 to y minus 1 is like going from here to here. That's 0 to y minus 1.
Okay.
So you're outside of the region that we're talking about.
Okay, yeah.
But if you say 0, yes, 0 is a y value. So that's why we're going from 0 to, when y goes from 0 to 3, x goes from 2 out to this function. That's what I'm writing here. So 0 is a y value, but y minus 1 is an x value. So you would never go, in this region, you would never go from 0 to y minus 1. It's like apples and oranges.
Okay.
So something's wrong. So other questions on this one? All right, how did the last one go?
Did you pick it down to 2?
You have to say, yeah, and the first thing that he said was, using x equals 4, you don't have to, because it's just, everything goes right through it, right? If you're going from left to right. But if you did use x equals 4, you'd end up using 3 integrals at the minimum. Because you'd have like this, like rectangular region down here, you'd have this triangle, and then you have this big triangle. So you don't need to have x equals 4 in this. That's why I say make the picture and then scrap the old limits. you scrap the old limits, the x equals 4 goes away, except for just you need it for the 5 up at the top. Okay, last one. Can I erase this? Any more questions? So make sure you write down my solution, and if you're still not clear, like study it and figure it out, why it makes sense. Okay? It's on the video too. All right, last one. So the last one is type 1 or type 2? Type 2, so we're going what first? Left to right. So the left side is 1/2 y. Here's x equals 1/2 y. That's the left side. The right side is square root of 25 minus y squared. What's that? This is circle, radius 5. So we're going, the left side is this, the right side is that, as x goes from, or y goes from 0 to, so it's like we're accumulating these strips up. And so is 2 radical 5 the intersection? It doesn't have to be. It could be lower down here, but it it does end up being the intersection there.
So if it was lower, would you just draw a line kind of?
Yeah, so then you'd have something like wherever it is, it'd be a line here. Yeah. Okay, so now we want to change the order, and we want to do bottom to top first. What does it mean for doing type? We want to change it to type 1. What's it going to mean for us here? Do we have to split it?
Yes.
Because of the bottom or because of the top? Because of the top, right? Because for a typical y value here, the top is this line, but then when we get to this x value, we have a different top, and the circle is the top. Okay, so, and what is this coordinates of this point here? Radical 5? And 2 radical 5? Right, because x is half of y, yeah. So that's that point, and so let's write it down here. So first, so we're doing dy dx. It means y goes from 0 to y equals, what is y equals here? 2x. And that's from left to right, so the leftmost one of these is here, which is x equals 0. And the rightmost is right there, square root of 5, right? So that's the pea green section, and now the teal plus y goes from 0 to, so we need to rewrite this y as a function of x, which turns out to be, if you do the math, you get that. And that's for x values from square root of 5 to 5. Is this making sense? So that one, when you change the order, you have to split it up because the top is in 2 pieces. There's the linear part of the top and the circular part of the top. Okay, so 3 web works. 1 due tonight at 7. 2 more due Monday when we come back at 7.